Okay, so today we'll deal with activity 9. Okay, so in this activity they might ask us the question. The question is very simple now. The question says, what happens when an acid is added to water, or water, let's consider water here. If you consider water, when this water is added to acid, what might be going to happen, right? So, and also they might ask this one more question, whether when these two get mixed with each other, right? Now what, is there any exothermic reaction happens? Exothermic, in simple words, heat energy, right? Whether heat energy gets released or not released, right? So this is the activity that we need to discuss here in activity 9. So this was very important activity because for suppose if you get passed and you become a scientist or something else, right? You need to know whether you need to add acid to water or water to acid, right? So that's the purpose. You need to. Now the experiment is very simple. For suppose if you had taken a test tube here. What is this? It's a test tube. Okay, if you consider the test tube. Now inside the test tube, okay, we will consider two cases. Situation number 1, we are going to take acid inside the test tube, and situation number 2, we are going to take water inside the test tube. In this test tube, let's consider this is test tube 1 and this is test tube 2. In the first case we have taken acid, in the second case we have taken water, right? Now in these two cases we will take one more here. We'll take another test tube. Okay, in here also we are going to take one more test tube, and inside these test tubes here we are going to add water, and here we are going to add acid, right? I think you are going to get the situation 1 and situation 2, right? In situation 1 you are adding water to the acid, and situation 2 we are adding acid to the water, right? Now in this case what happens is, when some amount of water droplets comes and hits the surface of this acid, right? Now what happens is, there might be more amount of heat energy released. Okay, it is an exothermic reaction. Exothermic means heat energy is released, right? So it's an exothermic reaction. But in this case what happens is, when water is added to an acid, okay, suddenly what happens is, acid's boiling point is very high rather compared to the water, because water's boiling point is 100 degrees centigrade, right? Within a fraction of seconds, due to the exothermic, that is nothing but heat energy released here, right? Now what happens is, the water gets to its boiling point, that is nothing but 100 degrees centigrade, right? Now this water comes and spills over, right? Spills. So in this situation, along with the water, the acid also comes out. Okay, little bit distractions happens. Okay, here what happens is, when water is added to an acid, what happens is it spills all over. Okay, so it might be dangerous, because if that acid comes and spills on you, what happens? Your skin may burns, right? So it might be little bit dangerous. But coming to the second situation, in the second situation what happens is, okay, you are adding acid to the water. That too you need to add drop by drop. What? One drop is added, and you need to use one more thing, that is nothing but a glass rod. Okay, so by using this glass rod you are going to stir the liquid. Okay, so in this situation what happens is, one drop of acid comes and hits the water surface, there might be little bit heat energy released. Okay, it is also an exothermic reaction, right? But within a fraction of seconds you are going to stir the liquid, right? Now in this case what happens is, there is a proper dilution of happens. Yes or no? There is a proper dilution of acid that is going to mixed with the water. So in this case we are going to add acid to the water. Okay, now they might ask you the question, is it safe to add water to acid? No, it is not safe to add water to acid. But the safest thing is, you need to add acid to the water. That too drop by drop with proper stirring. Okay, you need to remember this thing. Clear? So this is the case that activity 9 says, right? Wonderful. Now we'll deal with next activity, that is activity 10, right? So as we discussed in activity 7, you know about activity 7, right? In that activity we just dealt with acids conducts electricity or not, right? Acids conducts electricity. Okay, for this activity 10 we are going to take the same apparatus, same setup. So the thing is very simple. You need to take a beaker. Wonderful. We consider this is a beaker. Yes, wonderful. And inside this beaker we'll take some amount of substances here. We'll deal with the substances later. We need to take 2 copper rods, and 1 copper rod gets linked with the wire. Let's say it is a red color wire and it is attached to the AC plug. Its capacity is 240 volts AC plug. Okay, and this is going to be attached with the bulb. Okay, and the other end of the bulb gets attached to the other copper rod, right? So this is the thing, same apparatus that we have used in activity 7, right? But what is the difference between activity 7 and activity 10 is very simple. In activity 10 we just confirmed whether light glows in acids or bases, and in that case we simply said in acids and bases also what happens is the light glows, right? But in this activity 10 we simply say we'll take 2 substances here. We'll take an acid, that too in strong acid like HCl, and weak acid like a CH3COOH. Okay, it's a strong acid. If it is a strong acid, means it contains high amount of H plus ions. It contains more amount of H plus ions here. But if you consider CH3COOH, what happens is it contains H plus ions, okay, but the count might be little bit lower, right? But on the other hand, we'll take base here. Okay, this is an acids. Okay, these were the acids that are going to discuss in this activity 10. And coming to the bases, we'll take a strong base like sodium hydroxide. Okay, we'll take a sodium hydroxide here. This is a strong base. It contains high amount of OH minus ions. And we are going to take a weak base like ammonium hydroxide. It is a weak base. It also contains OH minus ions, but that too in fewer quantity, right? If you consider these 2 cases, okay. So let's do this with acids first. In acids, if we had taken HCl here, as we have discussed here, HCl contains more amount of H plus ions. Yes or no? Now in this case what happens is the bulb glows. Yeah, the bulb glows, but here it goes more brightly. Okay, it glows more brightly because HCl is a strong acid. Which acid? It's a strong acid. Wonderful. Coming to the other case, we have CH3COOH. It is a weak base. Okay, weak acid. Now if you replace the liquid with CH3COOH, in this case also the bulb glows, but it is not that much brighter. It is dull, right? If you consider in some situations what happens is there might be low amount of electricity passed through our houses. What happens is our bulb might glows very dull, right? Due to less amount of loads, right? So in the same situation also the bulb it glows but very lower. Yes, that's because it contains a few amount of H plus ions now. Okay, so this is the case. So by using this activity, if the bulb glows brightly, you simply said it is a strong acid. If the bulb glows very dull, we simply say it is a weak acid. Okay, but coming to the next case, we have a basis. If you replace the liquids with bases, let's say here we'll use sodium hydroxide. It contains OH minus ions. Okay, in this case also what happens? The bulb glows very brightly here. So we simply say NaOH. In this case the bulb glows brightly. So we simply say it is a strong base. What? Sodium hydroxide is a strong base. In this case what happens is OH minus ions gets accumulated inside here and they are going to move to the other carbon, right? So if you come into the next case, we have a ammonium hydroxide. It is a weak base. In this case what happens is the bulb glows but not that much brighter. It is so dull. Okay, the bulb might say it is a dull. So by using this we simply say in the basis also we simply say if the bulb glows brightly it is a strong base. If the bulb glows dull we simply say it is a weak base, right? So by using this activity 10 we should easily identify strong acids and weak acids, strong bases and weak bases. But what happens is, as time progressed, okay, there might be invention of several kinds of acids and bases, right? There might be stronger, weaker, and in between also we have a mild acids also, right? So this experiment is not suitable for mild, because in some situations what happens is, for strong and mild acids also the bulb grows brightly. It is not easy to differentiate between those. So that is the case they had introduced as pH scale, right? We'll discuss about the pH scale in the next video. Okay, thank you.